Hi everyone. I'm Vishal. I'm from VPN Service, and I'll be working on Hardware VTEP in Beryllium with Sam from OVSDB. This is Prem. He's a PTL on VPN Service, and he'll also be working on this with us. Anil, most of you would already be knowing from other presentations. What we are going to talk about is bringing in Hardware VTEP into ODL as a southbound plugin. Okay, so the use case of this comes from the L2 Gateway project in OpenStack, which is already there. What it brings is it allows you to bring tenant VM traffic into bare metals using overlay on top of rack switches. So it configures hardware Tor devices to bring and sets up tunnels between the OVS on your OpenStack side and bring the traffic over to them. So this is what the hardware VTEP schema looks like. Okay, you can do this with today you use the OVSDB schema to set up tunnels, create your VXLAN or tunnel ports. You configure the add points. The semantics on the hardware VTEP side are a bit different. So what we are going to discuss right now is start off with the YANG model that we need to finalize like any other project. First, we need to have a YANG model. We need to finalize the design on that, the things that we have lined up for this project during the Beryllium release, and maybe hash out a few discussion pain points that we have. Right. So, Sam?
Yeah, okay.
Does anybody need kind of a short overview of what we're trying to accomplish here?
Like I said, so
what problem is it solving?
like I said, L2 Gateway, what it brings is how you bring L2 connectivity between your tenants when some of their nodes are the VMs sitting in on an OpenStack side, and then they have some bare metal servers. Like, for example, a tenant could be having some bare metals where they're running their database server for some of their web servers. Web servers are running in a VM. How do you provide L2 connectivity between them? That's what L2 Gateway brings into picture. So, if you want there are nice tutorials and videos and all that because it's already a working implementation in OpenStack, I believe, kilo release. So that can give you more on that, but we don't want to focus because we got plenty to discuss already. Yeah.
So like Vishal said, this is the current hardware VTEP schema. And what we're going to try to, at least what we're going to start working through right now, the very first item we've got to work through, actually, they kind of list out some of the work tasks, from the OVSDB project side at least. You can see right off the bat we've got the architecture, and we've kind of been discussing that. We've kind of got that, but the next item that you see there is the YANG model. So everything's going to be driven, it's an MD-style application, so everything's going to be driven through that. So that'll be the piece that we're going to work on now today, is we're going to try to figure out this YANG model. And then you can see the rest of the items kind of fall out of that. Once you have your YANG model, you can create your southbound. You can create the NetVert application, which uses that. So if you look on the left side, this is how the model currently looks with the OVSDB project with the Open vSwitch schema. And you can see on the left, it's under the network topology model. The OVSDB node, that's kind of our root node. And from underneath that, we have, the Open vSwitch and the bridge. Those correspond to the, again, the Open vSwitch tables. Open vSwitch is kind of a root table. Bridge, those are bridges, switches. Termination points, that's the terminology from the network topology model. But it corresponds to the port and interface table. That's kind of how to read that. If you see the two lines in there, the top one's kind of what the network topology model, I guess, nomenclature is, and then underneath it is kind of the corresponding OVSDB table. So that's what we have today is the Open vSwitch and the OVSDB, the Open vSwitch schema. So what we'll try to do is go on the right. You can see at the node, you have the root table, whereas we've got this OVSDB :1, you've got the hardware VTEP :1. That's kind of the root now of where the whole hardware VTEP schema would lie. Node global, that corresponds again to like the Open vSwitch root table. And those stars mean 1 to many or 0 to many. So there could be multiple nodes there. And that corresponds to the connection. So every single OVSDB node, when it connects into OpenDaylight, it gets one of those node structures there, and like I'm saying, it represents the connection to that node. The middle one, node physical switch max, that's kind of where. So on the physical switch, when we talked about the schema, page up. As you can see over here on the left, the root table is global, comes across to the physical switch, the physical port. You've got those VLAN bindings to the logical switch. And then up there, the UCAS max, local and remote. Those are kind of the important structures. And how they map in. You can see the global table, the middle one, the physical switch. And again, that's very similar to a bridge in our Open vSwitch world, where we've got the bridges. Down beneath it, the termination points. Again, it's similar to ports and interfaces. It's the physical ports. And then it points over to the logical switch.
That's where
now-
things get a bit complicated.
Yeah.
Yeah. So you're only coming. Yeah.
I know about OVSDB. I know it's a database, you have a protocol, you can extract the data from the OVS using the
Right.
OVSDB protocol. How do you plan to extract the data from the physical switches?
So it,
Even before I start, like modeling stuff.
that's what the whole model of the Open vSwitch schema. The assumption is on those physical switches, you've got an OVSDB. It's an OVSDB node, so it's talking the OVSDB protocol. So,
So the physical switch is also supports OVSDB.
Yes.
yeah,
Yes.
yeah. That's key to the whole architecture. Yeah.
Okay, so the next question is that there are some modules out there, right? Define like TMF module for how to represent switching and ports, modules, and stuff like that. Why can't we just
You want to talk to that?
why can't we just take one of those modules and just model it in YAML?
This is the one that's available.
It's used pretty widely.
Yeah.
OpenStack now, plus
Yes.
other, VMware platforms have published a schema that solves this specific problem.
Yeah, we are not trying to solve here the problem of overlay and how to provide abstractions for that. We have physical switches running OVSDB, which is hardware VTEP schema. How do we leverage that? And we are the ones who bring them into the network, right? So that's what the focus is. We're not trying to solve the overlay problem here. We're not. I guess that answers your question.
Yeah.
Yeah. Okay. Yes, so basically what you see, logical switch is basically a collection of those tunnel endpoints where so logical switches are, so you have physical switches which would be in OVS terms roughly approximate to the bridges that you have or actual physical switches running OVSDB. Logical switches, and okay, before I get there, just a minute, I think it would be better to share this. So these are the tables, so just how do they, it's the same diagram, but kind of so physical switch, what it has, it is basically a collection of ports. When we talk of like how to configuration of tunnels, like ports that you have, which would be the physical interface or on the physical switch of yours. Each port has bindings like which are the VLANs it supports and all that, which will become relevant later. Okay, so now this is important. What is a logical switch? Logical switch is, if you look at over here, okay, we need to get a physical locator first. So physical locator is where you define your tunnel endpoints. Like, okay, physical locator means this is my VXLAN over IPv4 tunnel, and this is its IP address. You define endpoints. So you have, say, 10 physical switches which have those endpoints using VXLAN configured. And then logical switches collection of those physical locators. So let's say you have 10 physical switches. Each of them have 4 different endpoints. You can create a logical switch out of, say, endpoint 1 on switch 1 with endpoint 2 on switch 4. So some of them come together as a single logical switch, that L2 domain you would call it. So logical switch is not some actual switch, it's a collection of tunnel endpoints spread across multiple physical switches. So that's a kind of, it took me a bit of, still I'm trying to wrap my head around to it. Coming from obviously it's a different kind of a paradigm, but that's what our understanding is.
So I think that in practice, the logical switch typically represents a VLAN on the physical switch.
Yeah,
That's the layer 2 broadcast.
yeah,
The VLAN that gets ports attached to it,
Yeah.
or VLANs on ports
Yeah.
attached to it.
yeah. So here, because that logical domain comes to VXLAN, so it's a collection of those VXLAN endpoints who would participate in that particular broadcast domain.
Basically, you're referring to something. So in the hardware, I think we call it lattice, like layer aggregation ports, right?
Sorry?
You can take several physical ports or several VLANs and
Yes, yes,
aggregate them and
Yes.
consider them as the same one, right?
yes. So it could be spread across multiple switches, and
It's different than the lags, so.
Yeah.
Whereas lags, you're trying to combine a bunch of pipes
Yes.
into one. In this case, we're just using this as a way of.
yeah, it's
all the
creating an
hardware-
L2 domain,
Yeah.
basically. Like, so this is an interesting thing. So logical switch, if you look at it, we specify as a collection of physical locators. What our physical locators are, like we saw. This destination IPs. Type is currently supported type is only VXLAN over IP4, and that's what we'll be using. So it only supports VXLAN today. So and the IP is the tunnel endpoint IP, your VTEP IP. So think of logical switches, collection of VTEPs. So
By chance, do you have a picture of this?
to your ones.
No, no, how the whole network would look. You know, you have
Was
the
one of those
physical
L2
switch
gateway made this.
here. Yeah.
Yeah, I would have been good to have.
So, I have a question.
Yeah.
So, the library already support each hardware VTEP. So, it goes coming from OVSDB, the OVS instance. Do we have is the library already supporting that?
Library on which side? Obviously, that's what our agenda is.
Yeah, that's what I was trying to describe. So,
Yeah.
so we have the piece on the left right today. That's what we support today. The library itself, so well, we don't have that under. So the OVSDB project, right? We've got the library, which kind of does all the schema and the the protocol piece. Then on top of that, you have the plugin. Okay. So the library, it does support Hardware VTEP. So the schema is already there. It's not as well tested because this is probably the first real application we're using the Hardware VTEP. So there might be some bugs there, I'm sure, but yeah, it'll receive Hardware VTEP and it'll pass it up to some other application. So, but yeah, the plugin's not there. That southbound plugin, and that's kind of what we were trying to focus in on here.
You had that in your slides.
I was kind of trying to go through the work items there, I guess. We're on step 2, Yang model. The ODL neutron and OpenStack pieces, those are kind of a separate task, which are going on in coordination with this. But then, the infra work and then that hardware VTEP southbound plugin. That's what you're really asking about, though, is that piece of that plugin. So we figured, though, you'd start from that Yang model. You have to have that Yang model in order to create that southbound plugin. So,
Right now, there is OVSDB cell phone plugin is also there, right? Is network right now not going to that, or is it actually?
Netvert? Yeah, it's using that. Yeah. There's 2 plugins right now, just because.
Right.
There's 2, and we have to support VTN. Still needed. They're not MD-SAL compatible yet, so they're going through the old 80-SAL plugin side.
So,
But
so are we going to have a link between like a correlation or somehow to link the 2 nodes together? Should we do that in our VTEP? So should the OVSDB schema be
no, yeah, it's not needed. You can share. The way the OVSDB protocol works, you can have multiple schemas. So you could have Open vSwitch schema and you can have the hardware VTEP schema. But that use case, I could see, you know, when we're playing with the testing, we might for OpenVC, you know, when we're just testing, and we're just using virtual switches, but in the real
and
world.
you have to remember that these are like two separate schemas on OVS side. You can possibly have both of them or just one or the other. Maybe that could be another, do we force someone to have
Yeah.
both in place or not? So these are some of the questions we still have to answer.
Yeah,
But,
yeah,
it
but
would be good
practical.
not to tie them together.
Yeah, but practically, yeah. I mean, in the model, at least the way it's going to be used, they're complete. You know, you have OVSDB sitting down on an Open vSwitch.
So you don't
Yeah.
see any arrows going between them right now.
Yeah.
That's the sort of,
Yeah. The left side, that would be on the hypervisors the same way that we do today. On the right side, those are just going to be on physical switches. Yeah, so they'll be separate. And that's kind of, you know, when whoever starts finally writing this code on the OVSDB side, the plugin side, you know, those are some of the work items, you know, that there's common, you know, there's common code that could probably be extracted out and could be used,
so like,
you know.
which like you might need to be made into a library or a feature, or we'll end up duplicating or what.
Yeah.
Avoid duplication.
Do you plan on doing a separate bundle, or you plan on doing that from the southbound?
Yeah, that's my thinking, and then, you know, that's kind of part of this unconference too, however it wants to be implemented, if we have different ideas. But yeah, my thinking right now is, you know, the way that we have the southbound, you'd almost make the exact same thing, but now it's driven through a hardware VTEP schema. You know, and what I'd like to see out of that though is, you know, the whole transaction model piece. Remember that, you know, and how we, you know, all the fields are done, they're actually just action, you know, it's a command pattern.
Yeah, so that was my question, are you going to use the common fabric?
Yeah, I'd like to, and you know, right now it's tied into the southbound plugin, but that should be able to be extracted out. You know, the way that you create the transactions, you know, you have all the little helper methods which build the transactions, but then that whole engine, you know, the command pattern engine.
So are you going to make a third bundle, or is it going to be like, as the pattern, the same as the OVSDB, the third one as
Yeah, I guess it would have to be a bundle, right? In order to consume it, you know, hardware VTEP will be a feature, Open vSwitch will be a feature, but yeah, that, I guess that command pattern in the middle will have to be a bundle, I guess, so that they can be shared across the two.
What that means, it would require some refactoring effort on that side before.
It is,
So,
and
yeah,
you
so
can.
so it becomes that race against time in a way.
Yeah, and you know, if you want to start off, you can just, like you're saying, you can just copy the whole code base right now, the southbound, and you can start working on it.
extracting the common pattern that's already there? I'm not sure how easy it is to do.
Yeah, it's a work item. You know, that's the,
If that's where you want to go, that might
Yeah,
be
that's
the
where
first
you,
step.
yeah.
yeah, and that's, oops. Yeah, that's that infra work
Yeah,
item.
introvert part.
You know, there's another piece too. Right now, the library is actually stuck up underneath the OVSDB southbound plugin. It's loaded as a private library. But that's really easy to pull out. You just create a feature for the library. Yeah, so I don't know how we want to, do you want to walk through that model again then, since that's, if,
The young one.
yeah.
I think it will need a rework anyhow
Yeah.
right now, so what do we have to change?
Yeah. Can you describe kind of the pieces, if it makes sense, I guess?
Yeah, so physical port, logical switch we kind of discussed. So physical switch max is the MAC addresses, the MAC table of the different physical switches. So you know that for that, think of it like a MAC learning table. Similarly, there's a UCAST MAC table, which is where you learn the MACs of the VM side of it. So that would most likely be our operational data store over here. Yeah, and I think one question that we were discussing about before I came here was, okay, if you have OVS also, and this also, and those MAC tables, how do you share MAC tables? Do you or do you not? That would be, like, maybe on not physical switches, if someone is using OVS as a physical, you know, we have to support that use case, I believe. Still, I don't really look into that. Because OVS does MAC learning. Do we store that in operational data store today?
Well,
I
so-
don't think. Not
Yeah.
really.
So the way that we do it now, though, it's not really Mac learning. It's, I mean,
Right.
we learn it, you know, when
Yeah.
when the instances are popping up.
Right,
but then we
right. So we program
flows.
in. Oh, okay. We program flows, not the. Yeah, so there's no MAC table for us to program in
Yeah.
the DB. Yeah. So
Exactly.
they're more like
Program
flows.
flows and we go away.
Yeah. So here it's a table. So I think. So
So
think of make it more of a operational and then we replay? Or do you think this should be a,
Well, so the Mac table though, you know, I've got them, you know, so in the scheme of the Macs, you know, the UCAS Macs, they're local and remote or separate tables.
yes, yeah.
They don't map well into the topology model.
They don't.
So what I had done is, and you can see there in that physical switch, I've got Macs.
Right.
All I was going to do is, I
Oh,
was thinking,
okay. So
there's a
will
whole
be
list of
It would have
Macs.
local and remote as part of
Yeah,
it. Ah,
there'd be
Oh,
two
cool.
local and remote inside of that physical switch.
So that was one problem you were struggling, so.
Yeah.
So I propose.
Yeah,
Good.
and it's a list, and it's actually.
Right.
I thought it was a sequential, but it's key value.
Key value, right.
So, but does that work? So when a port, you know, as the packets come in off the port,
Right.
you know, it's going to have a VLAN, right? And
Right.
then you've got to jump into that logical switch table, right? 'Cause
Right.
there's a
It is. So
mapping.
VLAN is where that when you create a physical locator, you specify the VLAN bindings over there, right? And logical switch is collection of those physical locators.
Okay, and that's
So you support that.
should-
Okay, yeah, this logical switch supports these VLANs.
Okay. All right, so
So-
that should fit in the model. The way,
Yeah.
So we go from the port up to that logical switch.
Yes.
Um,
Maybe
this-
not just physical locator. We need some.
Yeah, so right now the physical switch is pointing over to the logical switch. How do we, so you've got the logical switch now, but eventually you're gonna have to find those Macs, right? You're gonna have to say, okay, is that Mac local or remote?
Right. So
How would we
that should-
converse?
Okay, so see, Mac learning happens within an L2 domain, right? So I would think of it not of a physical switch, probably more of a logical switch. Like it's very clear, right? That's what you're also should it be a property of logical switch, or think that would be logical switch. That's our logical switch is our L2 domain.
Okay.
Macs you learn are relevant within an L2 domain. Outside you have to go through routing tables and all that, which we are not doing. Right? So we tie it into the logical switch rather than physical switch. Because the physical Macs over here don't mean for the physical switch Macs. It's more like Macs learned on this bare metal side of it that I have learned. And so that's why the local and remote Macs, right? They don't use the term physical and logical. The local Macs and remote Macs, the Macs of the VMs that you want to learn over here as part of that L2 domain.
Okay. So, okay. We had our
So I
conversation.
think, yeah.
So does the model fit though? I mean, is that a good starting point?
Yeah, good
It's-
starting point. I think let's get started as and when issues will have to maybe retweak it. Yeah.
So not the physical switch, that's an OVS these days. So why aren't we using the same OpenD switch code? So why can't we make it with the same OVS? I'm just trying to understand the. So the physical switch, that's just an OVS instance, right? So it's a hardware switch that has an OVS instance.
No, it doesn't have OVS.
It has OVSDB running.
OVSDB with VTEP schema, not the OVS schema.
And it's running the VTEP schema.
Yeah.
And what within the hardware switch, it uses that schema to program the hardware devices inside the switch.
So that-
And to do this
Hardware.
VXLAN to regular VLAN.
Yeah.
So the hardware VTEP you have to compile with this. Let's say I want to have to compile it and install it as is to support it. Like by default, it's not supported. We just add a schema to
Are you talking about
the hardware VTEP.
on the physical device or
All the physical.
Well, I mean, yeah,
Yes,
that's
yes,
up
yes.
to the individual,
Yeah, so that's a prerequisite.
Yeah, so,
So if you want your device to be supported, you have to have it.
yeah, and so remember OVSDB though, when we talk about OVSDB and OpenV switch, they're two different things.
Yeah.
OVSDB is a database. There's a database and there's a protocol language. But it happens to be in our world though, when OVS world, you know, the virtual switch world, they're always tied together.
Yeah.
There's an OVSDB database, then there's there's a vSwitch D. and
Schema.
that's a switch.
It's a DB schema,
you know.
literally.
Yeah, and the schema goes into OVSDB, and then that configures the switch. So in the hardware VTEP, the only piece that you've got now on the physical switch is the OVSDB database.
Did.
Because the switch is there, the physical switch is there. But
yeah, it's just like another management.
Yeah.
yeah,
So, yeah. And the schema is just the VTEP schema, so they came up with, maybe they felt that OVS schema has too much of things or things that don't address all the use case. They wanted a simpler version or whatever. That's what they come up with. And yeah, if it were, then we wouldn't need to do all this. If they supported OVS and they said, okay, we're fine with it, we can do that, we wouldn't have needed this whole project or sub-project.
3, 2, 1.
Okay.
Okay.
And maybe continue some of the conference and discussions offline.
Yeah.
Yeah,
sure.
okay. Just starting point, the Yang model has already been hosted on JRED, so would appreciate more pair of eyes on that, more eyes on that, yeah. Yeah, it doesn't. This is based on he had discussions with Ed actually, so he gave some feedback. Yes, yes. So the Yang on Jared will not look like this, and we need to make some more improvements based on lessons learned from that how to write Yang model session yesterday. So would be incorporated, but and actually I wanted to show a running snapshot of a schema, but thing is. Alto Gateway folks, HP India, they could not come here, and they had this setup behind your VPN, so I could not access. So, and when we have meeting time.
Yeah, so we've got the OVSDB meeting, you know, and a lot of this work is coming out of the OVSDB project, I guess.
Yeah.
You know, we've got a
separate VTEP, Hardware VTEP meeting also, right? Tuesday, I don't know what time zone here.
Oh yeah, what time is that? 10 in the morning Eastern time.
7 PST time is meeting happens.
Yeah,
Day.
on Tuesday.
All those tasks which we need to do.
Yeah, I think I have the Trello page also.
Oh, okay.
Sorry. We have. So we have the task added to the OVSDB Beryllium Trello page. So
Yeah.
I think there are quite a few still on the to-do.
Yeah,
Feel free
you
to
can
check
see
them out.
to do work, you know, doing, done. You can look at the hardware VTEP pieces. This is our typical way when we work through our project. Anybody can work on a task. Anybody can pick up an item.
Actually, one item that's not here, I would really appreciate if someone can is, running VTEP on OVS and how that works. For now, all we have is on actual physical, which might be a problem for CA when we come to it, right?
Who said they would do that? Somebody had running scripts.
Oh, that was,
Who was that?
I don't know. I found some blocks, I got the VMs, I haven't had time to, but someone.
Yeah, somebody, maybe we'll ask Daya and see.
So how would you go, like, let's say I want to test that, so can I run that and have an OBS instance?
Yes, that's exactly what we were talking about right now. So right now, the existing setups we have that I mentioned, the HP folks who implemented Alto Gateway, so they have it with HP and Arista devices today. But it can be done with OVS, and that's what you were saying. That's one activity not listed here, but someone who can try that out.
And it's very similar, when you bring up OVS, OVSDB, you can use OVS, VS control, and you can run, you can start provisioning OVSDB. There's an OVS dash VTEP, or it was VTEP control.
OVS VTEP schema. Like when you bring up OVS, you normally specify OVS schema. You may not realize if you compiled OVS, you would have specified it. You might remember it. Similarly, you can bring up the hardware VTEP schema also both at the same time.
Yeah.
So you just instead of OVS.schema, you say HWVTEP.schema like that. So
So you load the schema, and then, like I'm saying, there's these control commands, and there's actually a VTEP
actually,
simulator.
I think I even had the schema somewhere over here. Let's see. Okay, yeah. So this is the schema, raw schema file, what it looks like. So it's trying to get a running version of the DB so that so it's a VTEP.ovs schema file. So you would similarly have for normal open vswitch.schema, right? So because if you Google hardware VTEP, you will get a PDF which defines the schema. It's not fully updated yet. This is taken off the master code base of OVS, so it has a few more fields, mainly related to BFD and one new table with some BFD parameters.
I think we're past time.
Yeah, but no one's coming up.
Yeah.
I think lunchtime.
Yeah. Okay.
Thank you, everyone.